So here it has been asked to show that the altitude of the right circular cone of maximum volume that can be inscribed in a sphere of radius r. So here we have a sphere having radius r, and one cone has been inscribed in the sphere, whose radius is suppose x, and this radius is r, and its height, the height of the cone, that is y, suppose. The height of the cone, that is suppose y. Now this length will be obviously y minus r, y minus r. Now therefore, here we have a right angle triangle like this. This is r, this is y minus r, and this is x. X is the radius of the cone. So now therefore, if we apply the Pythagoras theorem, then we will get y minus r whole square plus r square, sorry, plus x square, that is equal to r square. So therefore, x square will be equal to r square minus y minus r whole square. So now, therefore, the volume of the cone, inscribed right circular cone, that is equal to 1 by 3 pi x square into y. So that will be 1 by 3 pi x square. I can write it as r square minus y minus r whole square. So suppose if we simplify it, then this will be r square minus y square plus r square minus 2yr. So therefore this will be r square minus y square minus r square plus 2yr. So r square will cancel. So this will be y into 2r minus y. So this will be, so volume of the cone, we can say that will be equal to 1 by 3 pi into y into y, that is y square into 2r minus y. So the volume of the cone is coming v as a function of y. So now we have to find the maximum volume of the cone. So v of y is maximum. V of y is maximum when v of v dash y, that is equal to 0, and v double dash y, that should be less than 0. Then only y will be the point of local maxima. y will be the point of local maxima of the function v of y. So now therefore v dash y, that will be equal to pi by 3. I can take outside the derivatives, then this will be 2y into r 2r minus y plus y square into minus 1. So this will be pi by 3 into 4ry minus 2y square minus y square, that should be equal to 0. So therefore it means that 3y square, that should be equal to 4ry, and y cannot be 0. So therefore I can say 3y, that should be equal to 4r. So it means we have got that 3y square, that is equal to 4ry. It means that y should be equal to 4r by 3. Since y should not be equal to 0. So therefore we can say that the height of the cone, so no, we have to first, so therefore we can say that f dash 4r by 3, that is equal to 0. Sorry, it is not f dash, it is v dash 4r by 3, that is equal to 0, and we have to find then v double dash y, that will be equal to then, so this will be d by dy of the function, which is pi by 3. So this is pi by 3 will come outside. This will be 4ry minus 3y square, 4ry minus 3y square. So that should be equal to pi by 3 is a constant, so it will come outside, and this is 4r minus 6y. This is v double dash y. So now v double dash 4r by 3. So that will be equal to pi by 3 into 4r minus 6 into 4r by 3. So that will be 3 to the 6, that is 2 4 the 8. So this is 4r minus 8r, that is minus 4r. So that is that is coming minus 4 pi r by 3, which is less than 0, obviously. So therefore, we can say that at y equal to 4r by 3, v dash y that is equal to 0 and v double dash y is less than 0. So it means that the maximum volume, so or we can say that, so y equal to 4r by 3 is a point of local maxima of the function v, local maxima of the function v of y. So the maximum volume, so the maximum volume of the inscribed cone, or the maximum volume of the cone inscribed in the sphere, inscribed in the sphere, will be obtained if the altitude of the okay, the maximum volume of the cone inscribed in the sphere of radius r will be obtained if the altitude of the cone, is 4r by 3. If the altitude of the cone is 4r by 3. So hence proved. You have understood the concept. Thank you.